Hey everyone, welcome to another ALEKS tutorial video. This one we're going to be writing the electron configuration of a neutral atom, which is something that, considering this is the last video we're doing for Chapter 9, it's something that you are probably already familiar with. However, this particular ALEKS problem demonstrates a exception to what we might usually want to write as our ground state electron configuration, which is very important to know, and it will very likely come up on your exam. So this says write a ground state electron configuration for the neutral atom of each element. So this is a neutral atom. So because it's neutral, we know that the amount of electrons is going to equal the amount of protons. So manganese has 25 protons, and therefore we're writing an electron configuration containing 25 electrons. So we start with our 1s orbital, contains 2. Our 2s orbital, our 2p orbital contains 6, 3s2, 3p6, 4s2, we're at 20 electrons, and finally we finish it off with 5 electrons in our 3d orbital. So if we take these orbitals here, what this looks like is we've got our 4s orbital, and then the d orbital, which can contain up to 10 electrons. Our 4s orbital, as we can see, 4s2, this is filled. And our 3d5 orbital has every orbital filled with 1 electron. So all these orbitals are half filled. Now if we move on to chromium, looks like this is going to be the exact same thing. I mean, if this contains 25 electrons and chromium contains 24, it might be tempting to just, okay, well, I'll just copy this and paste it in here and just remove an electron. Like that. But that's wrong. And the reason that that's wrong is because when electrons are filling up the orbitals, they have two states that they are going to automatically reside in. They have two preferred states. Number one, which is the number one preferred state to be in, is having a full orbital, and number 2 is having a half full orbital. So if we look at chromium, the way chromium would be represented in this incorrect configuration here is that it would look like this. It would look like the 4s orbital is totally full, and then we have 1, 2, 3, 4 half-filled orbital, and then a totally empty orbital over here. But as it turns out, that is not how the electrons are going to inhabit these orbitals. Instead, rather than having one full orbital and this incomplete orbital, the electrons will borrow from the 4s and move it over to complete a half-full 3D orbital. So an electron gets removed from here and goes here. And so what that looks like is that it becomes a 4s1 3d5 orbital. And so what you see now is that rather than having a full orbital and a non-full orbital, we have a half-full orbital and another half-full orbital. And so that is preferred over having one orbital that's full and one incomplete orbital. However, this only will happen in select cases. And this is where you have a full s orbital and a d orbital that is one electron away from becoming either half full, in this case, 5, or completely full, like if we had, for instance, 4s2 3d9, rather than having a full orbital combined with an incomplete orbital, we would rather borrow an electron, making this 1, and put it in our d orbital, giving us a full d orbital. So in this case, we have a half-full orbital and a full orbital. But if it were something like 4s2 3d6, for instance, well, if we send an electron over here and make this 4s1 3d7, well, this would never happen because now we have a half-full orbital and an incomplete orbital. So you only lose an electron in your s orbital if it's going to complete either a half-full or full d orbital. And so that's the exception that you have to look out for when writing these electron configurations. So be careful when filling these out. So these are the final answers for the electron configuration of manganese and chromium. I hope this helped.